Now that I know these power meters are showing real potential, it's time to make them a bit more finished, a bit more usable and weatherproofed. This is the second one I made. It's always suffered from a little bit of drift, so I'm going to use it as the test for these future modifications that I'm going to make. The third power meter I made is currently on the bike, as it's working very nicely. So I've been having a look at the amplifier on this one, which I will put in a future video once I've finished having an experiment with it. But this video is going to be all about weatherproofing this internal space here where the electronics are, and also the on-off switch. So I've currently been using a toggle switch, which is not ideal, doesn't work with the end cap that I want to put on here. I turned a few end caps out of plastic using a drill press and a hacksaw. Took a while to get the diameters right and also install a groove for the O-rings, but this is what they look like off the drill press. There's the O-ring there, just takes up a bit of difference in diameters. The two cranks do seem to be different, and it obviously makes them a little bit more waterproof as well. And they are reasonable, easy push fit, but they shouldn't come out on their own, and they can be pulled out without too much difficulty. I had a look on the internet for push button switches and came across this one. Now it said in the listing title that it was latching, but it's not actually latching, it's just a momentary push button. But it does have a built-in LED, which would be very useful because I need an LED indicator on the power meter, and it's supposed to be waterproof. Now the fact that it's not a latching switch has now introduced me to the world of power latching circuits and all the possibilities that that now opens up for not just the power meter but also for the automatic shifter. Let's now have a look at the power latch circuit that I chose to use. A quick search of the internet and I found this helpful YouTube video. It demonstrates a few power latching circuits, but this one is the one I like the most. It's quite simple and also has a big advantage that the pin on the microcontroller that holds the circuit on can also be used as an input at the same time. If you're interested in how this circuit works, it's explained very well on the video. I went on the internet and ordered the 3 component types that I didn't have, the diode and the 2 MOSFETs. The smaller one, N channel, and the bigger one, the P channel, which is actually a slightly different type, but it's got very similar characteristics. It was just more available in the sites that I was searching. And so what I did, because they are all surface mount, was make up this weird arrangement where they are soldered onto the top of these pins. But I must get myself a breadboard one day, because at the moment I'm having to use this piece of Vero board, and also a proper power supply as well, because I'm having to use these lithium cells, which are okay, but they're unprotected, so you certainly don't want to make any mistakes. So when I got this powered up for the first time, I can't say it didn't work, but what I found was to get it to latch, you had to actually hold the button down for about 2 seconds for the Arduino to go through its startup procedure, enable the pin as an input with pull-up resistor. So obviously a short button press, it would just switch back off again, which is okay if you have to hold the button in. If it's for the power meter, for example, that would be alright, but I thought I can do better than this. I want it to latch on quicker than that. So I experimented for a little while with the capacitor position and moved it. It was originally it's on the between the positive and the gate of the power MOSFET, but I've now moved it down so it's between the gate of the N-channel MOSFET and the drain, so where it pulls down the power MOSFET. And I can show you what the voltage is like now on the gate of the power MOSFET with that capacitor in place. At the moment the MOSFET is off, it's pulled high at its gate. Press the button, drops low, and then you can see the capacitor charging up, and then as the pin on the Arduino is enabled, it pulls it low through the other MOSFET. And if I hold it, and that's it switching off, and it rises immediately back up to high again on the gate. Press it again, and go see that capacitor charging up just until the Arduino kicks in. But it now works rather nicely, so a short press and it latches on, and when that light flashes, that's when the pin is enabled as an input. So it's about 2 seconds. But I've got on here at the moment some button code, and it does different things depending on how long I press the button for. So if I press it till it flashes once, it will flash a few times. So that could be, for example, with a power meter, it would be the zeroing function, and then if I hold it down for 3 flashes, it turns off. I've also got connected up to this a reed switch, which can be used to power it on as well. So I've got plans for that, which I'll put in a future video. With a working circuit that included surface mount components, and I also knew I needed more than one of them, I decided it was time to get some circuit boards made up properly. So I went on to this easy EDA, drew up the circuit diagram here, and then had a go at laying out a PCB. This is my first attempt. As you can see, the capacitor is actually in the wrong place on this one, but I spent probably way too long shuffling components around and eventually came up with this final design. I then sent off the files straight from a well-known PCB manufacturer in Shenzhen, China. My own custom-made circuit boards. They arrived surprisingly quickly. I only ordered them 5 days ago. This is the first time I've ever ordered circuit boards custom made from China. So let's open them up and have a look. There it is. Looks like all the tracks are there very nicely. There's one right in there which is very small, but it seems to have turned out perfectly. Very good. We've got should be 3 holes, yeah, with plated 3 holes. So I know it's a bit of a weird combination of surface mount and 3-hole, but it should work alright. I don't have surface mount resistors. I don't want to invest in a whole load of those. So for this one, I'm going to use 3-hole. It should be small enough overall, this circuit board. It's pretty small. And you can see the Arduino is about the same width. So let's get soldering. Never actually done any serious surface mount stuff before. So I'm using the tack it down with a bit of flux method. It up with a pencil. You can see just how tiny these things are, and these are not even the smallest surface mount. Some of the resistors are even smaller than this. That one. Cool. Looks okay, I think. Yep. So now we move on to the much larger MOSFET there. And this seems absolutely huge in comparison, but still a pretty small thing. There you go. Yep, cool. Looks good. So that's all the surface mount done. There's a bit more solder on those pads than I would like, but it will be good enough. So now I'm going to do the 3 resistors and 1 capacitor. And do that off camera because I don't need the microscope ability of the phone. Well, I'm pretty pleased with that. It's turned out very nicely. So now let's solder some wires temporarily onto the inputs and outputs and then see if it actually works. Is the circuit all wired up? Just one last connection to make and we can see if it works. And this is the first time I've powered up this circuit. And the first time you put power to it, the Arduino will latch on, but it should. I'll wait for 3 flashes, switch off, and latch on again. Perfect. Now all I need to do is get all this lot wired up and fitted inside the crank there. That's it for this video. Thank you for watching.